Hello guys, so today the topic will be inverse of a matrix. So we will see in this video we will see how to solve 3 cross 3 matrix by row operation. Okay, there are two methods of finding the inverse of a matrix. One will be adjoint method, which we will do in determinants, and one will be row operation method, which we will do in matrices. Okay, so we will be doing row operation method, row or column operation method. Our topic is how to find the inverse of a matrix. Now there are two methods to find the inverse of a matrix. The first one is by row operation method. Okay, this will be in matrices. The next one will be adjoint method in determinants. Okay, this will be done in another video. So here we will see inverse of a matrix by row operation method. Okay, so what are the things you require? Prerequisite. It means what are the things required to understand this topic. Okay, so let's see, that is properties of row and column operation. Okay, so these properties, if you don't know, these are very important. If you don't know, you will not be able to understand this. Okay, so you need to understand, you need to know the properties of row and column operation, then only you'll be able to solve the matrix or find the inverse of a matrix by row operation method. Okay, so the properties you better write down, and I will explain each property by using an example. So first is addition of one row or column to the other. Okay, so if you are doing column operation, you will be using these kind of operations where columns are involved, and if you are using row operation, then you will use this kind of operation where rows are involved. Okay, now they are saying row I times. Now the first is addition. We add two rows. Okay, so you can see this is the row where operation is applied, and with this row see another row has been added. Okay, so let's see an example on this. Example, if I have a matrix A, suppose I have 1 2 3 and 2. Okay, now suppose I want to make this element, I want to make it 3, as I'm saying. So what will you do? How can you make this element as 3? You will just add 2 here, right? But in row operation directly you cannot add 2. You have to take use of another row. So here what I will write, my target is this, it is in the first row. So I will put my row 1 under operation, and then I will say row 1 has to be added to row 2 to get 3. Clear? Just focus on this element, nothing else. Don't look at everything, just focus on one term at a time. Okay, so now when you add, what will you get? See, row 1 is under operation, but row 2 is not under operation, so row 2 as it is you can write 2 2. But row 1 will be row 1 plus row 2, so 1 plus 2 will be 3, and 3 plus 2 will be 5. This is how we will get. Clear? So if you are, suppose you have another one here, 1 3 2 2. Okay, now this is the same matrix. Okay, I want to bring up 4 here using column operation. So what will I do? C2 I will put under operation because C2 has that element which we are concerned with. So C2 plus C1. Okay, so which is, you can see C1 is not under operation, so I will keep C1 as it is. Okay, and C2 is 3 plus 1 is 4, and 2 plus 2 is 4. Okay, so I'm getting 4 here. Okay, now let's see the second one. Subtraction. Suppose I have 1, 3, 2, 2. Okay, I will be showing you row operations, all of them, because mostly we use row operation. Column you can see it by yourself. So this is my matrix, and I tell you I want 1 here. I want 1 here. So what will you think? You have to subtract 1. Okay, so there is a 1. Okay, I am saying it by myself because you need to use these. You need to learn how to use this. Okay, that's why I'm making it up. So because you want to make 1 here. Okay, so what will you do if I want to make 1 here? We will see later that we cannot decide what we want to bring here. Okay, just for now I'm saying that if I want to make 1, so what will I do? Row 2 I will put under operation because this element is in row 2. So row 2 minus row 1. So it's simple. You can see that this will become 1. So row 1 is not under operation, so you keep it as it is. This one 2 minus 1 will give me 1, and 2 minus 3 will give me minus 1. So this is how you will get 1 here. Okay, look at one element at a time. Clear? So this is how you will use row. Next operation is multiplication of row by a scalar. So what do we mean by this? Suppose I have a matrix 1, 3, 2, 2. Okay. Now here what I can do is I can multiply any row with a constant. Okay, suppose I want to make this 1. Okay, this multiplication, keep in mind, it can be done like this. I can multiply any row with some constant like this, or I can multiply by something like this. Okay, not necessarily 2 will be there, but you can see that this multiplication operation deals with multiplication as well as divide also. Okay, so you will not write a row I divided by 2. Instead you will write 1 by 2 multiplied by row I. Okay, so multiplication, you can multiply with a fraction, you can multiply with an integral number. Okay, so by saying that, if I want to make a 1 here, you can do by subtraction, no doubt. Okay, if I want to make 1 here, you can do subtraction, no doubt, but I want to show you this operation for now. So let's see this. So row 1 should go under operation because the element is in row 1, and if I want to make this one 1, so I will multiply by 1 by 3 into row 1. Clear? So what will be my A now? It will be row 2 remains as it is because it is not under operation. And this will be 1 by 3, and this element will be 1 by 3 into 1, right? So it will be this, and this one will be 1 by 3 into 3. So this will give me 1. Clear? So these are examples. Just to understand. Okay? You can write down only the operations. These examples you will know. If you start using, you will know. Okay, let's see the next operation. This operation is the main one which we will be using mostly. It involves addition, subtraction. Okay, here I have written plus, you can write minus also. Okay, here I have written multiplication of one row column by a scalar and adding or subtracting from another row or column. Okay, so in place of this there can be minus also. So suppose I have a matrix like this: 1, 3, 2, 2. Okay, now I want to make this one 0. Okay, how will I make it 0? Now see, there is a 1, right? So can I multiply 2 to this 1 and subtract from here? Yes. So see, this is my 2, minus 2 I multiplied with this one. So will it give 0? Yes. So I will get this. I will get 0 here in place of this by doing this. So what I will do, this is in row 2. So I will say row 2 should be under operation. So what will I do? With row 2, I will subtract 2 times of row 1. I'll multiply 2. That's what I have done here. I multiplied 2 here and subtracted from this row 2. That's what I have written here. Row 2 minus 2 times row 1. And you can see here in that row, multiplication of one row or column by a scalar. See, this row I multiplied with a scalar and adding or subtracting. Here I did subtraction, here I have written plus. Okay, so if you want to get 5, then you need to do plus here. So like that, you can write plus also. I have written minus. Okay, so this is what this point, this operation says, that you can multiply a constant to one row and subtract it from another. This is what it says. Okay, so this is another operation which is very important. This is very important. If you did not get, please rewind and see again what I did here as well as here. Okay, so let's go to next one. Next property, where k is a constant. Okay, this k can be constant. I am writing 2, it can be 3, 4, 5, whatever it is. Next one is interchanging rows and columns. Okay, interchanging rows and columns. Suppose you have a as 1, 0, 2, 3. Okay, you can do this. Row 1 interchanging with row 2. Clear? So this will become 2, 3 and 1, 0. This is how they interchange each other. Okay, so these are the 5 operations which you need to by heart to, in order to find the inverse of a matrix by row operation method. Okay, next thing we need to know is multiplicative inverse. So now what is multiplicative inverse? In smaller classes we have seen that if you are given a number 3, so teacher will ask you that what is the multiplicative inverse of 3. So you will say 1 by 3. Why? Because it will give us 1, the identity element, right? So here also, if you want to find the multiplicative inverse of a, then we need to multiply a by 1 by a. That is, we write like this: a multiplied by 1 by a, that will give you the identity element 1. Or in other words, we can write a, and this can be written as a to the power minus 1 equals to 1. I can write, okay. But the same thing can be written like this. From here, a goes here, and then I can say this part is here. See, a into 1. This a goes here, it is here. Clear? So we can write like this for numbers. If suppose a is some constant, so I have shown you here also. Can I write this as 3 equals to 3 into 1, right? So this is what we have written here. Clear? Now you see, so similarly in matrices we use a equals to a into 1. Here this will be treated as identity matrix. Okay, in numbers we had 1. In matrices we will have identity matrix. You know what is an identity matrix? A matrix which looks like this. Okay, for 2 plus 2, for 3 plus 3, it looks like this: 1, 0, 0, 0, 1, 0, 0, 0, 1, right? It looks like this. So if for column operation you will use this method, okay, and for row operation you will use this method. I'll show you how to use this, okay. But know that when you are doing column operation to solve a problem, you will write a equals to a into I. When you are doing row operation, you will write a equals to I into a. Okay, And when you are using column operation, you will not use row operation in that. If you are using row operation, you will not use column operation in that. Okay, so here where I is the identity matrix and A is the given matrix. Okay, now see, if we want to find the inverse, okay, in row operation for a 2 cross 2 matrix, we need to proceed in a predetermined way and transform the given matrix to an identity matrix. Okay, so we need to given a matrix. Okay, this is 1 3 2 2. This is a given matrix. Okay, so we need to transform the given matrix, so this matrix has to be changed into identity matrix. Okay, but in a predetermined way. Why I'm saying that, we will solve a example and I will show you. See, you have to proceed in this way. First you need to make this element here 1, then go to this, then you need to make the second element 0. This one will make 0, then you move in this direction, then you make this one 1, then you move in this direction and make this 0. Clear? If you don't move like this, you will see there will be a big problem that every time you use row operation, you will see changes come in all the rows. Okay, you will see changes come in all the rows. You don't want that. Okay, that's why we need to move in this direction. When you do a number of problems, so 6 7 problems if you do, you will know that we have to move in this direction. Okay, so let's see an example. Let's solve the example. So we are given this. Okay, so I'm going to use here row operation. I'm going to use row operation. That means A equals to I will use. Clear? So here I will write like this. So let A is equals to I A. Okay. So A I will write 1 2 2 minus 1. This one is 1 0 0 1, and this A will remain as it is. Clear? Because we know if we multiply A with its inverse, I will get I, right? So what I want to do here is change this matrix to A inverse, so that this multiplied by this should be equals to I. Okay, and this I will be this one. Previously I told you that you need to transform the given matrix to identity matrix. Okay, so by that I mean, you see that this is my A matrix, this is my A matrix. I need to transform it to I. Okay, and in that process this will change to A inverse. Okay, so that is the simple idea, that change this to I, and in that process this will change to A inverse. Clear? So let's see how to do. Now whatever operation you apply on this side, on left hand side, same operation will be applied to right hand side. Okay, not in this A. Remember, we need to get a situation like this: I equals to A inverse A. Okay, here. Okay, so first thing, I need to make this one as 1, right? So it is already 1, so I don't need to worry. Then I need to go to this one, I need to make this one 0, right? So how will I make 0? I will multiply 2 in this one and subtract from here. Okay, this is very important. Multiply something to one row and subtract from the other. Without multiplying directly, I cannot do row 2 minus 2. Remember, I cannot do row 2 minus 2. I need to multiply row 1 with something and subtract from here. That is why we make here 1 so that we can use 1 to make others 0. So row 2 tends to row 2 minus 2 times row 1. Clear? So see what happens. Row 1 is not under operation, so I keep it as it is. Row 2 you can see 2 here minus, look at this operation and look at this term. Row 2 is 2 minus 2 times row 1 is what? The element from row 1 is 1. This will give me 0. Now look at this term and this operation. So row 2 is minus 1 minus 2 times row 1 is 2. So this is minus 1 minus 4. So this is minus 5. Clear? So whatever operation you applied on the left hand side should be applied on the right hand side. Okay, should be applied on the right hand side. So let's see what we will apply on the right hand side. So row 1 will remain unchanged. Row 2 will be row 2 minus 2 times row 1. So row 2 is 0 minus 2 times row 1 is 1. Okay, look at this element. Row 2 minus 2 times row 1. Okay, so this is minus 2 and this one will be 1 minus 2 times row 1 is 0. So this is 1. Clear? Now 1 and 0 is done. Now you need to move in this direction. Here, this you need to make 1. To make this 1, what will I do? I can use addition here. Okay, see, minus 5, that is row 2 plus 3 times row 1, 3 into 2, 3 times row 1, so minus 5 plus 3 times 2, so this is 1. Yeah, so I'm getting 1. I'm getting 1. What happens here if I add? See, 0 plus 3 times 1 becomes 3. So do you want 3 here again? No. So I will not do addition. Clear? Addition will be wrong for me. Because where one place I'm getting 1, but the other one is changed. Yeah, so here always think of multiply. Okay, multiply. What I will do, if this was not changing, then you could have done. Okay, but this one is changing. So what will I do? Row 2 tends to minus of 1 by 5 into row 2. Yes, why I'm using multiplication? Because multiply anything to 0 becomes 0. Okay, so see here, this implies so row 1 is unaffected as it is 1, 2, but in row 2 I need to multiply, so 0 into, see this element, minus 1 by 5 into 0, it will remain 0, but here minus 1 by 5 into minus 5, 5 cancel, minus minus plus, so I will get a plus sign. Clear? And the same operation you have to apply here. Row 1 will not change, so here you see minus 1 by 5 into row 2, right? So minus 2. So this is 2 by 5 because minus minus is plus. And here it will be minus 1 by 5 into 1, right? In this one. Okay, so this is minus 1 by 5. And this is here. Here. So rough you need to do rough. Don't try to do it in your mind. Try to do the rough. Okay. So now if this is the last term, I want to make it 0. So how will I make 0? I will multiply 2 here and subtract. Okay. So if you move like this, then it will be easier to multiply and subtract from other rows. That is the purpose of moving in a predetermined way. So row 1 should be under operation, row 1 minus 2 times row 2. Clear? You see here, see, row 1 is under operation, so row 2 I will write as it is. Okay, so row 1 minus 2 times row 2 is 0. Clear? So this is 1 only. Okay, now next one, row 1 is 2 minus 2 times row 2 is 1. So 2 minus 2 is 0. So this is what we are getting. Is to row 1 remains the same. Row 2 remains the same. So 2 by 5 and minus 1 by 5. And see, how will I change row 1? Row 1 is 1 minus, okay, row 1 is 1 minus 2 times row 2 is how much? 2 by 5. So which is equals to LCM is 5 minus 4, which is 1 by 5. And this one, row 1 is 0 minus 2 times row 2 is minus 1 by 5, which will give me 2 by 5. Okay, so you can say now you are getting I. This is your A inverse, this is your A, this should be this is I. So this is the matrix. This is the inverse of this matrix. If you multiply these two, you will see, you will get I. Okay, so therefore A inverse is equals to 1 by 5, 2 by 5, 2 by 5 and minus 1 by 5. So this is your answer. Okay, so you should not be confused. If you are confused, please rewind it and see again. So this is it for row operation method. Okay, so I'll see you in next video. Thank you for watching.